Hello, today we are going to talk about the topic of electrochemistry focusing on electrolysis. What is electrolysis? Electrolysis can be broken down into electro and lysis. Electro refers to electricity and lysis refers to split or to decompose. So electrolysis is the use of electricity to break down or decompose a compound, usually an ionic compound in molten or aqueous solution. What is electrolysis used for? Electrolysis is used to extract pure elements from a compound. So how is it carried out? Electrolysis is carried out in an electrolytic cell. So a question might pop up. How does it look like? How does an electrolytic cell look like? Well, let's find out. So here's an electrolytic cell. It consists of a battery, a container, an electrolyte, and electrodes. Oh, don't forget the wires. So let's talk about the anode. The anode is the positively charged electrode connected to the positive terminal of the battery. Anions are oxidized and discharged here. And here's the cathode. The cathode is the negatively charged electrode connected to the negative terminal of the battery. Cations are reduced and discharged here. So the anode and the cathode are known as electrodes. Ions are discharged by losing their electric charge by gaining or losing electrons at the electrodes. And this is the electrolyte. The electrolyte conducts electricity, which usually is an ionic compound in molten or aqueous state. And not to forget the battery. The battery is a dry cell and it is an electrochemical cell. An electrochemical cell is a cell that converts It's a cell that converts chemical potential energy into electrical energy. And the dry cell, the battery, acts as an electron pump that uses potential difference to move electrons from the cathode to the anode. So what happens during electrolysis? So let's find out. So here's our electrolytic cell with molten sodium chloride as our electrolyte, and we are using carbon electrodes. And do note the carbon electrodes in this case are graphite. So the battery transfers electrons like a pump from the anode to the cathode, as seen here. Note that the electrolyte, the molten sodium chloride, should completely consist only of sodium and chloride ions, but for illustration purposes, I'll only include two pairs of ions, as seen here. So at the anode, anions move towards the anode and give up electrons, being oxidized, resulting in chlorine gas being produced and chloride ions being discharged. So do remember that the anode is the positively charged electrode. So since the chloride ions are negatively charged and opposites attract, the negatively charged chloride ions are attracted towards the positively charged anode. And that's why the chloride ions are able to move towards the anode. So let's take a look at the animation where the chloride ions are being converted into chlorine gas and giving up electrons. So let's see. So two chloride ions come together and give chlorine gas and electrons are given out. So now let's move on to the cathode. At the cathode, cations move towards the cathode and receive electrons being reduced and resulting in sodium metal being deposited and sodium ions being discharged. So as you can see here is the sodium cations, and they will now move towards the cathode, where they gain electrons and become sodium metal. So in the electrolyte, the cations and anions move towards the cathode and anode respectively. The presence of these mobile ions in the electrolyte allows electricity conduction. What can be electrolytes then? Well, only molten ionic compounds or compounds that can produce or form ions in aqueous solution can be an electrolyte. So this is due to the fact that the presence of free mobile ions are acting as charge carriers to allow electric current to flow. with the definition of electric current being the rate of flow of electric charges, with the ions being the electric charges, as they have a positive and negative electric charge. So the ions are also the very thing being discharged during electrolysis to give pure elements. So non-electrolytes are substances that do not conduct electricity under any condition. So some examples of non-electrolytes include ethanol and water, as these are covalent, simple covalent structures, and they do not ionize in any condition except for water, where water is dissociated during electrolysis. But pure water does not allow electricity to be conducted, as there is no free mobile ions present. So the differences between how electrodes and electrolytes conduct electricity shall be seen here. So here's a table where electrolytes conduct electricity by electrolytic conduction, while electrodes are conducting electricity by electric conduction. So do note that the electrodes are inert electrodes and they do not react. So the method of conduction used by the electrolytes by electrolytic conduction is by the use of free mobile positive and negative ions, while electrodes by electric conduction, the method of conduction is the use of free electrons. So what's the effect of the conduction then? So the effect on the electrolytes of upon conducting is they are decomposed to form new substances, while the electrodes, after allowing conduction to occur, they remain chemically unchanged. So here's electrolysis of molten ionic compounds. During the electrolysis of molten ionic compounds, we only have to consider the ions that constitute the ionic compound. For example, the electrolysis of molten sodium chloride, we will only have to consider the sodium and chloride ions in determining which ions are discharged at which electrode. So the reaction at the anode will result in chlorine gas being produced, and the reaction at the cathode will result in molten sodium metal being formed. So the overall reaction is molten sodium chloride is electrolyzed to give molten sodium and chlorine gas. Meanwhile, the electrolysis of aqueous solutions of compounds. So during the electrolysis of aqueous solutions of compounds, we have to consider the ions that constitute the ionic compound and the ions that form during dissociation. So the splitting of a compound into ions of water. So namely the hydrogen and hydroxide ions. So since there will be more than one cation and anion, they compete for discharge at the electrodes. This is where the selective discharge rules of cations and anions come into play. So the selective discharge of cations. We have covered on a previous video on the reactivity series that the more reactive a metal, the more it prefers to ionize and remain as an ion. So do check out that video for more information, and I'll link it right here. And to sum it all up, I will just sum it up as the more reactive the metal, its cation is more difficult to discharge, and thus a less reactive metal's cation would be more easily discharged from the electrolyte. So here is some cations listed down, and as you can see, we know potassium is from the top of it's one of the most reactive metals we have, and however, it is the least easily discharged due to its high reactivity and its preference to stay as an ion as compared to converting itself to its metal form and not ionized form. So the ease of discharge increases down the reactivity series. So the cations of metals below hydrogen will be discharged during electrolysis. And now let's carry on into the selective discharge of anions. So the selective discharge of anions. For halogens, the less reactive the halogen, the more easily its anion is discharged. while sulfates and nitrates are usually not discharged from solution, as this is due to the high amounts of energy needed to discharge them from solution. So, hydroxides are usually discharged in preference to sulfates and nitrates to form water and oxygen gas. So, here's the ionic equation to show the electrolysis of the hydroxide ion and how it's discharged to give 2 moles of water and 1 mole of oxygen gas. So, here's some ions listed out, and it says that the ease of discharge decreases as it moves down from the ions. So the sulfate and nitrate ion are usually not discharged during electrolysis. And the hydroxide ion is most commonly discharged as it is the easiest to discharge. So the exception to the selective discharge of anions rule. So when the concentration of an anion is higher than others, it is more readily discharged. For example, during the electrolysis of concentrated sodium chloride solution, the hydroxide anion will be discharged, preferentially to the chloride anion, correct? However, the number of chloride ions is greater than the number of hydroxide ions, and therefore chloride ions are discharged at the anode in preference to the hydroxide ions to give chlorine gas instead of oxygen gas. So as you can see here, since the concentration of chloride ions is greater than the concentration of the hydroxide ions, chlorine is oxidized to give chlorine gas. So let's move on. So with that, thank you for watching, and do leave a like and remember to subscribe. See you next time. Check out my other videos here.